This video will outline the new features found in ADAPT PTRC 2018, released October 2018. And to do this, we're going to run through an example or a model setup in the PT or RC input. We'll go ahead and select OK, and we're going to create a new file. We're going to go ahead and navigate, and you'll notice that in the new version we have two new codes that are selectable. These are Hong Kong 2013 and Australian 2009. When the European code is selected, shown here, and we have a one-way slab or a beam selected, the program will consider and provide options for inclined stirrup angles and also for the compression strut angle per EC2 for one-way shear design. And this will be shown under material reinforcement in these two entries for angle of shear reinforcement with beam and also angle of concrete compression strut with beam. The calculations and methodology and the outcome of the shear reinforcement is then dependent on these two inputs and also the code requirements per EC2. In addition, for EC2, the program now includes a check to ensure reinforcement is provided to meet 1.15 times the cracking moment for unbonded post-tension beams. We'll go back to Project, Design Settings, and you'll notice here the second setting says Design Capacity Exceeding Cracking Moment. By default, the program will check this, again for unbonded PT beams when EC2 is selected. If the user wishes to disregard this, they can select the option here, check this box, and this provision will be disregarded. For EC2 and one-way slabs, the program checks the thickness of the slab when shear reinforcement is required per EC2 section 9.3.2. For example, in this model we have a one-way slab spanning 8 meters. If we go to the span geometry, we can see that the height or the thickness of the slab is 185 millimeters. So the required thickness when shear reinforcement is required by design is 200 millimeters. The outcome of this particular example will show in the report that at sections 1, 2, 3 from the beginning and also the last 3 sections, the program tags and shows where the thickness is insufficient, meaning that the required reinforcement for strength for one-way shear does not have the right thickness meeting the requirement of 200 millimeters, and that is tagged in this report. When a one-way slab is modeled with the inclusion of transverse beams, and this is independent of the design code selected, under the design code here we're going to go ahead and select ACI. This is still metric, but we'll select a different design code other than European. And we can see that in the design settings there's a new option to include or not include the transverse beams for the calculation of minimum reinforcement at supports. If this is selected, the minimum reinforcement based on the code requirement will include the geometry or area of the transverse beam. If this is deselected, the minimum reinforcement at the support where a transverse beam is present will only include the area or geometry of the slab. When a post-tension beam or slab is being designed using the software, there's an additional design option that's shown here for the calculation of precompression. If you select this option, the program will calculate the required force necessary to meet precompression at all sections along all spans. Each span is subdivided into 20 segments, therefore the check is made at all segments. The governing PT force will be the maximum required force necessary to meet precompression at any of those sections. If this is deselected, the program will base the calculation of the force necessary to meet the minimum precompression at the midspan of a slab or a beam. To provide an example for the requirement for P over A, we have a two-way slab that we're showing. This is an ACI, it's US units, and this is a segmental input. And we can see if we rotate the slab here, we have a drop at the first support. We have just a prismatic section here for the slab, and then we have this really deep section that might, for example, be a transverse beam for some reason that might be spanning out to other supports out of plane. And then we have a drop here and a drop here. So if we take a section through any of these sections, either whether it be at the first support, the span, this deep beam, again the slab, or the interior drop panel, the program should really control the force necessary to meet P/A based on this particular segment right there. And again, this is a two-way slab, so we'll go next. You can see it's using ACI, and we're considering all sections for P/A. This is currently checked. So if we go to the span geometry for this particular segment, we'll go and select more. You can see this is set to non-prismatic. This is a 200 by 48 inch deep beam. So if we take 200 times 48, the geometry or the area is 9,600 square inches. Okay, and we'll go ahead and let me go ahead and cancel out of here. And we're now going to go over to the pre-stressing requirements. So if we look at the average pre-compression, the minimum required is 125. That's the setting that I've made as the user. If we multiply the area of the deepest or controlling section, 9,600 square inches, by 125, we get a required force of 1,000. In previous versions of the program, the required force was always based on the middle segment, the controlling, let's say, section in this middle zone, which was typically just the geometry near the midspan. So we'll go ahead and run the analysis for this example. Okay, and in the PT recycler screen, we can see that the PT force is 1201. So looking at this, and if we want more detail, we can go to tab number 3, and the P/A required in span 1 is 1200. The P/A required, or excuse me, the force required to meet P/A is 1200. And you'll notice that this has changed from what the default would be, which would say P/A mid in parentheses. Here it says GOV governing in parentheses. So this tells us that a section other than midspan is really governing that particular requirement for P/A. Okay, we're going to go ahead and we're going to exit out of the recycler. I'll just go back into the input, and under, let's see, this is under design settings. Let me skip over one more screen here, and I'm going to deselect this option. Okay, and I'll make sure I select next to store that. And if I go back and rerun, okay, after I rerun and I go back to tab 3, we still see that the requirement is 1200, but this has changed to mid. Remember, when the selection is deselected or not selected, the program bases the required force based on the middle segment of the span. So the middle segment is not just the exact midpoint of the span, it's a region within the middle of the span. So if we'll go back and we'll just exit again, and I'll go back into the input under the geometry, and this particular piece is within the middle 50% of the span 1. So if I go ahead and just select more, and I make that segment 12 inches, for example, I'll say OK, and then next. And again, my setting under the design settings still shows that this option, or this new option, is deselected. So we'll go back and rerun again. And you'll notice again in recycler, now the force required is actually 300 in span 1 and 2. And under required PT force, that shows 300. Now, one thing you may not have picked up on was the first run when I was considering P/A for all sections, this second span requirement was actually 444, which was dictated and governed by the drop cap. Either at the interior support or at the end support, they were the same geometry. Once I turned off that option, you'll notice this is actually 300. So both spans are being modified based on that setting. The default is not to include this, and it's basically to do what previous versions of the program have done, which is base it on midspan, but the user now has the option to consider all sections. And then finally, the last feature and improvement that was made was when you use the calculated force method or the tendon selection method. If I switch this to tendon selection, which essentially means that the program is now calculating the long-term and short-term losses for the tendons. I'll go to tab number 5, and you can see there's some number of tendons selected based on an average force over the length of the tendon. I'll go ahead and I'll recycle, and then I'll go ahead and exit. So when this particular tendon selection method is used, and the program actually calculates the elongations under the summary report, you can see now that the elongations are reported here in the summary report. And this depends on whether this is live, dead, live, or dead live. So the user defines in the recycler window how the tendons are anchored, and the outcome of the summary sheet would report the elongations. If you have any questions, please contact us at support@adaptsoft.com. Thank you.